All right, let's get right into it. We are talking about an incredible visitor from deep space today, an interstellar comet by the name of 3I/Atlas. Now, what that means is it comes from that huge empty space between the stars. And believe me, it has been putting on one heck of a show, a really strange one, too. And that brings us to the big mystery we're unpacking. This traveler from a whole other star system has basically changed its look right in front of us. So the big question is, why? What's going on here? Yeah, we're calling it an interstellar chameleon, and for good reason. I mean, think about this. It's only the third one of these things we've ever confirmed. The third. And it's already proving to be quite the shapeshifter. So, when astronomers first got a good look at this comet with the Gemini South telescope down in Chile, it looked, well, kind of reddish. That was our first impression, you know? It looked like a pretty standard, dusty, rocky object, the kind of thing you'd expect to find just chilling out at the edge of a solar system. But then, boom, everything changed. A brand new image comes out and it shows something totally different. That reddish wanderer, gone. And now we're looking at this brilliant glowing green comet. So, two big questions. How did we even get this shot? And what in the world does this color swap actually mean? Okay, so to get to the bottom of that green color, we've got to talk about the camera. And let me tell you, this was not your average point and shoot. This new picture comes from Gemini North, which is perched up on Mauna Kea in Hawaii. We're talking about a beast of a telescope with an 8.1-meter mirror. It's truly one of the most powerful eyes we have on the entire planet. But, the telescope itself is just one piece of the puzzle. The real magic? That's in the instrument that's bolted onto it. And that instrument is called the Gemini Multi-Object Spectrograph, or GMOS for short. Now, don't think of it like a simple camera. It's more like the super high-tech science machine. Basically, it has this wheel of filters that lets it see the universe in really specific colors or slices of light. So, here's the play-by-play of how they get that final image. First, the massive telescope has to lock onto this comet, which is just zipping across the sky. Then, GMO snaps these separate black and white pictures, but each one is through a different color filter, one for red, one for green, and one for blue. After that, astronomers take those individual layers and stack them all together. And voila, you get that one absolutely stunning full-color photograph. Okay, so now we know how they saw the green. But that's just half the story. The real question is, why is it green? Let's figure out the chemical culprit behind this whole thing. It all comes down to a molecule called diatomic carbon, C2 for short. So as the comet swings closer to the sun, things heat up. Its ice starts to turn directly into gas. It vaporizes. And that gas creates this glowing atmosphere around the comet's core. We call that a coma. And one of the main gases in that coma is C2. It's a super simple molecule, literally just two carbon atoms stuck together. So what makes it glow? Well, you can thank the sun for that. The sun is blasting out all this powerful radiation, and it's slamming into those C2 molecules. This gets them all jazzed up, super energized. And the only way for them to calm back down is to release that extra energy. And they release it as light. It's this really cool bit of quantum physics, right? It just so happens that C2 molecules are built in a very specific way that when they release that energy, it comes out almost entirely as green light. And that's our green glow. And this is where things get really profound. Because a color-changing comet from another star sounds super exotic, right? But this green glow, it's actually one of the most normal things a comet can do. It's a classic sign we see all the time in comets from right here in our own solar system. And what that tells us is that the basic chemistry, the ingredients that make comets here, might be the same around other stars too. It's a hint that the building blocks of solar systems might just be universal. But hold on, because the science is only one part of this incredible story. How this discovery was actually made is just as cool, and yeah, it involved some pretty surprising detectives on the case. See, this wasn't your typical scenario of a few astronomers huddled in a dark control room. Nope. This was a live event, shared in real time with students and science fans who actually got to be part of the discovery as it was happening. It's all part of this awesome outreach program called Shadow the Scientists. The Gemini Observatory basically lets the public tune in to a live observing session. You get to see exactly how the pros do it, how they pick their targets, get the instruments ready, and actually collect the data. And what's crazy is that this was the second time they'd pointed the telescope at this exact same comet for the program. Talk about a repeat performance. So to recap, the comet changed color and basically taught a live science class while doing it. Pretty cool. But what's next? What's the next chapter in its story? Because its journey through our neighborhood is far from over. And here's the thing you always have to remember about comets. They are famously unpredictable. Just because it's acting normal right now doesn't give us a crystal ball. We have no idea what it's going to do next as it starts its long trip back out into the void. What scientists are really going to be watching for are things called late reactions or outbursts. See, as the comet whipped past the sun, it soaked up a huge amount of heat. Some of that heat can get trapped just below the surface. And even as the comet is moving way out, far from the sun, that stored up energy can suddenly, violently release itself in this big explosion of gas and dust. We just have no way of knowing if or when something like that might happen. So that's where we're left. This incredible visitor surprised us all. It switched from red to green, and in doing so, it gave us this amazing clue that the ingredients for making comets might be the same all over the galaxy. So, what other secrets is it still holding on to? What else is this messenger from another star going to show us on its long, long journey home?